using statistical methods, controlling the quality using statistical methods. That is the quality control. Here, as you see here, question 1, it shows a new industrial oven has just been installed. This is question 1 of the tutorial. I was planning to take 2 today. So question 1 is a new industrial oven has just been installed at the bakery. To develop experience regarding the oven temperature, an inspector reads the temperature at 4 different places inside the oven each half an hour. The first reading taken at 8 AM was 340 degrees Fahrenheit. Based on this initial experience, determine the control limits for the mean temperature. Mean means average, average temperature. Determine the grand mean, X double bar. Plot the experience on a chart. Interpret the chart. Does there seem to be a time when the temperature is out of control? Based on the initial experience, determine the control limits for the range. Plot the experience on a chart. Does there seem to be a time where there is too much variation in the temperature? Do you have a calculator with you? Calculator and paper to write? Because I need answers from you.
Yes, doctor.
Yeah, no problem. Then I need answer from you. Let me explain to you clearly. Okay. So we take temperatures here. For example, in a system, we take temperature at 4 different points in a furnace. Oven means furnace. So hope that you can see this, the desktop. See, at 8 AM, I take, for example, this is a furnace. This is a furnace. Example, this is a furnace. I measure temperature at 1, 2, 3, 4 points. At 8 AM, I take 4 points, temperature 40, 50, 55, 59. So how many samples are there? 4 samples are there. Then 8:30, again 4 locations I take, again readings 44, 42, 38, 38. 9, 9:30, 10, 10:30. I take 1, 2, 3, 4. How many samples? 1, 2, 3, 4, 5, 6 samples. But you see here 4 readings each I take. 4 thermocouples are connected and then we take the readings. Now we need to plot a control chart. In the control chart, I will not tell you which type of chart. Plot a control chart. Which type you have to identify. If you look at it, it is you are measuring the real values, 40 degrees Celsius, 50 degrees Celsius, real values you are measuring. So you have to go for a chart which is called control chart for variables. Control chart for variables. You have to go for control chart for variables. So in control chart for variables, we have 2 charts. The 2 charts are control chart for variables. We have 2 charts, X double bar chart. This is the chart for mean or average, and R bar chart, which is the control chart for range. These are the 2 charts. So why we go for control chart for variables or control chart for mean, MEN, mean or range, is because why we go for control chart for variables is because we measure the real value like 40 degree, 44. We measure the length, width, height. For example, here we measure the temperature and then we are going to plot. That's why we go for control chart for variables or which consists of X double bar and R bar chart. Now here the upper control limit and lower control limit, we have to calculate them. Upper control limit and lower control limit for this chart. If you look at them, the control limits, as I explained before, for X double bar chart and how do we draw them is, let us start with X double bar chart. In X double bar chart, the middle line is the control limit, which is X double bar mean of the means. So then upper control limit and a lower control limit. Upper control limit is calculated using the equation X double bar plus A2 R bar. And lower control limit is done using the equation here, X double bar minus A2 R bar. A2 is a constant. X double bar is the mean. We call it as grand mean. Grand mean. A2 is a constant. R bar is the average of ranges. Average of ranges is R bar. So we need to find all this, and this is in y-axis. In x-axis is sample numbers. So here what I do first is sorry. Here what I do first step, I find X bar here. How I find X bar? So can you find X bar for here? 40 plus 50 plus 55 plus 39 by 4. Can you find it?
46.
So this value is 46, and here what is the value? 44 plus 42 plus 38 plus 38 divided by 4. Here we are calculating mean. Remember, mean or average. How much?
40.5.
40.5.
5.
So 40.5 here. Okay. Okay, 40.5. Let me see here. Just a minute, please. Discard and come back here. So how much it was here? 46. And how much it is here?
40.5.
Yeah, what about this? Very quickly. This is mean. Yeah, very quickly. Yes.
44.
44. Then what about this? 39 plus 39 plus 41 plus 41 by 4. Average, mean.
40.
40. Okay, what about this?
$41.5.
41.5. The last one. So this is mean.
39.5.
39. So we got X bar for all set of samples. 1, 2, 3, 4, 5, 6 sets. Can we calculate grand mean? Grand mean is X double bar equal to, can you calculate it using this? Take the average of all these 6, 46 plus 40.5 plus 44 plus 40 plus 41.5 plus 39.5 divided by 6. Number of samples are 6. Samples, sample 1, sample 2, sample 3, 4, 5, 6 samples. So can you take the average of the mean? That is called the grand mean. Average of the mean is called grand mean. How much?
41.916.
41.916. Very good. So you until here it is clear to you, right?
Yes.
Yes, doctor.
Yeah. Now we go for, this is the grand mean, X double bar, and this is X bar. Now we go for range. Remember, range is represented by R. Can you calculate what is the range here? You take maximum. Maximum is 55. Minimum is 39. Difference between maximum to minimum. 55 minus 39 here. How much?
16.
16. Similarly, next one. 44 is maximum, minimum is 38. How much?
6.
6. So maximum minus minimum. Can you calculate third, fourth, fifth, and sixth?
Third 6.
Third also 6. Okay.
Two.
Correct.
Nine.
Okay.
1.
So R bar is the average of these range values. What is the meaning of range? In a set of observations, maximum minus minimum is called range. We have maximum minus minimum values in a set of observations. So can we calculate mean of the range values here? 16 plus 6 plus 6 plus 2 plus 9 plus 1 divided by 6. Can you calculate average of the ranges?
6.66.
6.66 is the average of ranges. Now let us calculate x double bar and lower control limit and upper control limit. Can you calculate? Substitute x double bar equal to 41.916. A2, yes, let us go. How many number of samples here?
6.
6 samples, right?
Yes.
For sample.
So 6 observations, right? And
Yes.
each observation consists of how many readings you take each observation? First sample at
4
8.
read.
Yeah, first sample at 8 a.m. How many readings you take? 4. Second one 8:30. How many readings? 4. Third sample 9. 4 readings you take. 9:30. 4 readings you. So total how many samples you have? 6 samples.
6.
Correct, Khalid?
Yes, doctor.
Now, if you go here, find A2 from the table. Table is given shown here. You can find according to the sample size. According to the sample size, you can find how many what is the value of A2. So what is it?
0.48.
Sorry?
0.48.
D3,
0.
D4.
2.
Correct, Khalid?
Yes.
Now, when we apply here, what are the values here? Can you calculate it and tell me upper control limit and lower? You have all values here. Substitute and tell me the values. Huh? You got A2. Take A2 from here. Have you calculated this?
Doctor, can you change the slide? Go to the next slide.
Yeah, before that, I want to explain to you something. In each set of observations, right? How many samples you take, how many readings you take in each observation. Of course, you have you have taken 8 samples, like 6 samples, like 8, 830, etc. But each one, how many number, sample size? That value need to be taken here. That means the value what need to be taken is 4, corresponding to 4, not 6. Is that clear? Each one, that means at 8 o'clock, you have how many samples you have taken? 4, right? Then 8:30, you have taken 4, right? So each sample, how many observation that need to be taken here for the sample size. So corresponding to 4, you have to take 0.73. These values need to be taken. Please write it. What are the values you have? Is that clear?
Yes, doctor.
Yeah. Now, if now what you have to do? You take the values here. I will write it. A2 equal to 0.73, D3 equal to 0, and D4 equal to 2.28. Now these values substitute here in the equation. Can you substitute it and tell me the values here? How much? Substitute x bar, x double bar,
Abar
A2
45.
0.73. A2 0.73. Okay, Khalid?
Upper control lower 45.8618.
Upper is 40. What is the value of A2?
A2 0.73.
73. How much is the value? Upper?
45.8618.
Okay. Okay, lower?
36.1382.
1382, right? Now I'm
Yes.
going to draw the graph here. Look at that. In that graph, what I will do, my control line, the middle line will be x double bar, which is grand mean, which is 41.916. And there is upper control limit and there is a lower control limit. Lower control limit is 36.1382 lower control limit, and upper control limit is equal to 45.8618. Please cross check the values. I don't have the answer. That's why I'm telling you. Okay. Okay.
Okay, doctor.
Yeah. Azam?
Yes, doctor.
You are with me, right?
Yes, doctor.
Now what we have to do, you plot sample 1. How many samples you have? 1, 2, 8 o'clock is 1, right? Or I can put 8. Sample 1 at 8, sample 2 at 8:30, 9 o'clock, then 4 or 5, 6, 7, and finally 8. Have you seen it? How many samples? 8 samples. Correct? What is the mean value of first x bar value? First one, first sample, x bar value 46. So here you are plotting x bar. So first value is 46. So first value 46. No need to be, you don't need to take any scale, but you need to plot it outside because 45 is the maximum and you are getting 46. 45 is the maximum and you are getting 46. It is out of the limit. Second is 40.5. 40.5 you can mark approximately here. No need to go for a scale. 3 is 44. 3 is 44 here is 3. Then 4 is next 4 is 40. 40 has to be somewhere here. This is 40. Then 5 has to be 41.5. 41.5 is somewhere here. And the last one 6. 6 is 39.5. 39.5 is somewhere here is 39.5. So there is no 7 and 8 here. So then what you need to do, this is approximate values, no need to put exactly, but so you need to join them. It is difficult here. You need to join them. How to join them is like join. It's difficult, you may get, because controlling here is difficult for me. I'm trying my level best to. This is the control chart. All of you, it's clear? All of you clear?
Yes, doctor.
Yes, doctor.
Yeah. Now this is called a control chart, but one of the point gone out of the control limit. See what we are plotting in the y-axis? X bar, the mean value, the average values. What we are plotting in x-axis? Sample 1, 2, 3, 4, 5, 6. X bar, but one of the values gone out of the limit. So your comment will be, what is the result of analyzing the graph? When we analyze the graph, since one is above, sample 1 X bar mean is out of upper control limit. Hence we say that process is out of control. Is that clear to you? This is the comment. What is the comment? Sample 1 X bar mean is out of upper control limit. Hence we say that the process has gone out of, process is not under control. Why the process is not under control? Because the mean value gone out of the upper, either upper or lower. If it goes beyond upper, if it is between these two, no problem. Between upper control and lower limit, no problem. If it is away out of upper control limit or lower control limit, we say that the process is out of control. This is the final conclusion. Is that clear?
Yes, doctor.
Very good. Now what we need is we need to draw one more graph. What is that graph?
Range.
Yes, we need to draw range. So very quickly we can draw a range. How to draw range is, so we have upper, sorry, it is better to discard this and come back. Range chart. In range chart, you have 3 lines: upper control limit, middle, lower control limit. R bar, can you give me what is R bar? Upper control limit. Can you give the values?
6166. الأبر
Yes, no, R bar.
15.
R bar. R bar. R bar.
R bar 6.66.
And upper?
Upper 15.1848.
Lower?
0.
0. If it is minus, you can take it as 0. So here you are going to plot not R bar, range values. Here you are going to plot a range. And here y-axis will be sample number, like before 1, 2, 3, 4, 5, and finally 6. Let us go back and see what is the range value for 1. 1 is 16. Look at that. 1 is 16, which is again gone out of control limit. 2 value range 2 is 6. Second sample range is 6 here. 6. So we go here, 2 is 6. 6 is just below here. And then 3. 3 is again 6. 3 is also 6. So 3 is 6. 4 is 2. 2, 9 and 1. 2, 9 and 1. Look at that. So now we need to connect them properly. As you see here, this is 1, 2, 3, like this. We have to connect it. So this chart is called R bar chart or control chart for range. So this is also control chart for variable, but it is for a range chart. Here you can see again, point 1 has gone out of the control limit. We say that process is out of control. Why process is out of control? Because the range value has gone or exceeded the upper control limit. Hence, we say that the process is out of control. Is that clear to you, all of you?
Yes, doctor. Clear.
Clear? Khalid?
Yes.
Yes, just doctor,
Lima?
clear.
Yes, okay. So I'm going to deliver only this for today. And I think it is clear if both are, if even any one of them, even if it is below lower control limit, out of control. If it is between upper and lower, no problem. The process is under control. If any one point, like in X bar chart, one of the point out of upper control limit, in R chart, one of the point out of control, the process is, we say that the process is out of control. Even any one of them goes beyond the limits, we say that either up or down, we say that process is out of control. So this is called control chart for variables. Okay. Based on the initial determine control limits, determine control limits means upper control limit and lower control limit. We calculated upper and lower. Determine grand mean. Grand mean means X double bar, grand mean. Plot the experience on a chart. This is the experience on the chart. Interpret the chart. Interpretation is here. Sample 1 of the X bar chart is gone out of upper control limit. Hence, we say that the process is out of control. This is the interpretation. There seems to be a time when the temperature is out of control. Which time temperature is out of control? Can you tell me which time temperature is out of control?
8 o'clock.
8 o'clock. The answer is yes, 8 o'clock. The first one, 8 o'clock is out of control. Based on experience, determine control limits for range. Control limits for range is this, D4 R bar, D3 R bar. We calculated it here. I didn't explain to you about D4 R bar. I explained, right? Correct? How we calculated D4 R bar? D4 corresponding to 4, 2.28. D4 is 2.28. So 2.28 multiplied by R bar. R bar is 6. Oh, we did. Okay. How much is the value? As you explained, 15, right? Khalid, 15.1848, right?
Yes, doctor.
Yeah.
Yes.
And this becomes
15.18.
this becomes 0. So then this is the upper and lower limit of D4 chart. Sorry, R chart, range chart. Plot the experience on the chart. This is the plot. Now, what we have does seem to have any time too much variation in the temperature. Do you think any too much variation in the temperature? Variation means range, change. Do you think too much variation here anywhere? Do you think too much variation, change in any of the point?
Between
No,
1 and
doctor.
2.
Yeah, but in 1, not between 1 and 2. It is in 1. See, big change in 1. That is the reason. Clear?
Yes, doctor.
So does there seem to be a time where there is, yes, 8 o'clock, there is a big variation 8 o'clock because the range is coming as 16, other range is 6, 6, 9, 2, etc. But first one at 8 o'clock, big variation range 16, that is shown here. So this is called control chart for variables, X bar chart and R bar chart. Here we plot the exact value, the numbers, whether it is temperature, time, or distance, or length, or diameter, we measure it and we plot it. That's why it is called a control chart for variables. So X double bar chart, control chart for mean, and the range chart, R bar chart. Is that clear to you, all of you?
Clear, Doctor.
Okay, thank you very much for attending. So we will continue next class. Okay.
Thank you, Doctor.
Thank you. Thank you very much.